Alright, so 8.3, show that quadrilateral is a parallelogram. These properties come from the properties that we identified in 8.2. These are the converses of 8.2. So in both pairs of opposite sides of a quad are congruent, then the quadrilateral is a parallelogram. What you're going to be using is side, side, side to prove that these two triangles are congruent. And therefore, you will have alternate interior angles, both parts, converse, therefore you would have a parallelogram. The next one of 8.8, in both pairs of opposite angles of a quadrilateral congruent, then the quadrilateral is a parallelogram. You would come down to angle, angle, side to repeat the process of CP, CTC, and then you would get to alternate interior angles, and then by the converse of alternate interior angles converse, you would get parallelograms again. Finally, if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. Parallel. You get side, angle, side, congruent. So go from there, and then if diagonals bisect each other, then the quadrilateral is a parallelogram. So, ways to prove that a quadrilateral is a parallelogram: show both pairs of opposite sides are parallel. I would recommend slope if on a coordinate plane. Congruent, this would be distance formula. Both pairs of opposite angles are congruent. One pair of opposite sides are congruent and parallel, so slope and distance. And show the diagonals bisect each other, that would be distance formula. Okay, so going on to the problems, what theorems can you use to show? So, parallel, parallel, congruent, congruent, we come down to theorem 8.9. Okay, diagonals bisect each other. (8.10). Parallel, congruent. 8.9. Opposite. And last but not least, 8.7. Okay. So finding values. Bisected. Okay. Same thing with this one. Set them equal to each other. Okay. This one you're going to set them equal to each other. Since these are bisected, we're assuming that these get bisected as well to prove. So you set those equal. And then the problems that I really like are 10 through 12. So, opposite angles right now are congruent. If we're assuming that they're congruent, this would have to equal x. So you have 111 plus x equals 180. So x equals 79 degrees. These ones here, 3x, 3x, 4x plus 5, consecutive interior angles. And then same thing with this one here, 5x minus 10 plus 12x minus 14. Set that equal to 180. And then you would solve the question. Okay? What additional information is needed in order to prove that the quadrilateral is a parallelogram? You need to understand everything that's being asked of you. So look at it this way. So if AB and DC are parallel, so that means AB and DC are parallel, you would either need to know that AD and BC are parallel or that AB and DC are congruent. So or that AB is congruent to DC. AB is congruent to DC, you would need to know that AD is congruent to BC, or AB is parallel to DC. Angle DCB, so DCB is the big angle located here, is congruent to DAB. So if you have opposite angles, you would need to know that angle ADC is congruent to ADC to CBA. DE is congruent to EB, which is a diagonal, so you would need to know that AE is congruent to EC. Angles of D and A are supplementary, so since those are supplementary, you would need to go back to 8.2. You would need to prove that, we'll skip that one for right now. We'll come here to DCA. Congruent to this, you would need to know, since those would be alternary angles, you would need to know that AB is congruent to DC. And then if CDA, if this angle here and this angle here are consecutive interior angles, that means that AB and DC would be parallel. You would need to know that AB is parallel to DC. Okay.